Hi students, in this video I'll be going through exercise 10F question 14. Alright, so let's read the question. So the diagram shows the plan view of a rectangular table ABCD, which is positioned at the corner of a room. Okay, given that AB is 1.4, BC is 0.6, angle OAD equals to theta, and angle AOD is 90 degrees and CED is also 90 degrees where theta varies. Okay, so theta varies means you can actually shift the table around, okay, such that the angle at which it makes to the wall, the side OA, right, will be different, right? Okay, show that OE is 1.4 cosine theta plus 0.6 sine theta. Right, so for this kind of question where they want you to prove something like this, you always need to divide the length that they want you to show, right, into two parts. So as you can see, it's quite obvious that OE, right, we will divide into OD plus DE. Alright, so we will try to find OD and DE separately, and then we add it together, and hopefully we get this expression for OE. Alright. Okay, so let's try to find OD first. Okay, so OD is over here, that is in the right angle triangle OAD. Alright, so do we know the length of any sides now? Okay, so we actually know AD, right? Because this is a rectangular table, so opposite side should be same length. So AD should also be 0.6. Okay, so we know AD, angle theta is over here. So for the triangle OAD, AD is actually the hypotenuse, right? Okay, then OD, the side that we want to find is actually the opposite side. So in this case, we will use sine, right? So in this case, sine theta will be OD over AD. Okay, so sine theta will be OD over AD, and AD is 0.6, right? Okay, so in this case, OD will be equals to 0.6 sine theta. Okay, so this is where this 0.6 sine theta comes from. Okay, so now we will try to find a DE, and then when we add together, we should be able to show this. Okay, so this is angle theta over here, right? Okay, so what would this angle be? This angle ODA. So angle ODA will just be 180 minus 90 minus theta, right? Okay, so let's write the working here. Angle ODA equals to 180 angle sum of triangle minus 90 degrees minus theta, and that will give us 90 degree minus theta. Okay, so the angle over here, ODA is 90 degrees minus theta. Okay, this is a rectangular table, so angle ADC should be 90. Okay, so this will allow us to find this angle over here, angle CDE. Alright, so let's find angle CDE. Okay, so angle CDE is angles on a straight line. So angle CDE plus the 90 degrees CDA plus angle ODA is angle on a straight line, right? So angle CDE will be 180 minus the other two angles. So minus 90 minus ODA we have found earlier, which is 90 degree minus theta. Okay, so if you do the calculation, you actually get theta. Okay, so this angle over here will also be theta. Okay, so do we know any lengths in the triangle CDE? Okay, so same thing, opposite side of rectangle have equal length, so this will be 1.4. So again, this is the hypotenuse of the triangle CDE. Okay, the length that we want to find DE is actually the adjacent side. So in this case, we will use cosine. Okay, so cosine theta will be DE, alright, DE over 1.4. So DE is 1.4 cosine theta. Okay, so adding these two together, therefore, OE equals to OD plus DE. We will get okay, so we'll write it the other way around. Okay, so okay, anyway, we'll write this way plus 1.4 cosine theta. Okay, but then they want the 1.4 cosine theta in front, so we'll just switch it around. Okay, okay, so shown. Okay, so this one will be in meters. Alright. Okay, so this is how you show the first part of the question. Okay, the second part, find the value of theta for which OE is 1.1. Okay, so now they say that OE, okay, so they lead it in such a way that from O to the point E, E is the horizontal line, right, from the highest point of the table. Okay, so but in this case, it's the top view lah. Okay, so it's the, okay, actually we can still say like the uppermost point. Okay, so now they want to find the value of theta that will give us OE to be 1.1. So OE we have already shown that is this. Okay, so we equate this to 1.1. Okay, so we are able to solve the equation just like this. So what we need to do is we need to use the R formula to convert this 1.4 cosine theta plus 0.6 sine theta. Okay, so for most questions, usually they say put it in the certain form, R cosine theta plus alpha, or theta minus alpha, or R sine theta plus alpha. But in this question, they didn't say. Okay, so how do we decide what do we let it be? Okay, so usually how I decide is this. Okay, if I see that the cosine, the question, the previous step they asked us to show, right, the cosine is first, right? Then I will use R cosine, right? Okay, then this is a plus. So remember for cosine, right? Addition formula. Okay, to get a plus, we open up, this has to be theta minus alpha. Okay, so when we straight away open up now, cosine theta cosine alpha plus R sine theta sine alpha. Okay, this is what we'll get, right? So over here you can see cosine theta cosine theta. So R cosine alpha will be 1.4 and R sine alpha. Okay, so this is sine theta sine theta. So R sine alpha will be equals to 0.6. Okay, so we can find R, okay, by taking 1.4 square plus 0.6 square. Okay, this should give us square root 58 over 25. Okay, so use your calculator to compute it. Okay, so it's square root 58, square root 25 is 5. Okay, so this is what we'll get. Okay, then let's find tangent alpha. So tangent alpha will be sine over sine. So it will be 0.6 over 1.4, right? So alpha, if we do tangent inverse, you will get 23.20, right? So therefore, 1.4 cosine theta plus 0.6 sine theta will be equals to square root 58 over 5 cosine theta minus 23.20, right? Okay, I'll continue the question in this part, all right? Okay, because there's not enough space. So remember, we are asked to solve this equation. So we have already proven that 1.4 cosine theta plus 0.6 sine theta, right? We can express it in this R formula form. Okay, so we'll replace this into the equation. Okay, we'll do over here. Okay, so therefore we have square root 58 over 5 cosine theta minus 23.20 degrees equals to 1.1. Right, so we'll bring this square root of 58 over 5 and divide the 1.1 divide by that, all right? So we'll get cosine theta minus 23.20 equals to 1.1 over 50 square root 58 over 5. So you will get 0.72219, right? So basically now we'll find the basic angle 72219. So the basic angle will get 43.765 degrees, right? So now cosine is actually positive, so I'll continue below over here. Okay, so cosine is actually positive, so it's either the first or the fourth quadrant, right? Okay, but based on the diagram, okay, we can't be finding the fourth quadrant answer because the fourth quadrant answer will be 300 plus, right? So if you bring the 23.20 over to add up, okay, the angle theta will be 300 plus. So angle theta can't be so big, right? Okay, so it should be the first quadrant answer. So 43.765, right? So bring the theta over to add, you will get the answer of 67.0 degrees. Okay, so to 1 decimal place. Okay, let's look at the last part 3. Say the maximum value of OE and the corresponding value of theta. Okay, so we have already expressed OE in this form already. Square root of 58 over 5 cosine theta minus 23.20 degrees. Okay, so the maximum value will depend on the value of this. So the maximum value of a cosine function with amplitude 1, right, is 1. Okay, then the minimum will be maximum will be 1, minimum would be -1. So since they want the maximum, then we'll take it to be 1, right? So the maximum OE equals to square root 58 over 5 times 1, which will be square root 58 over 5, right? Okay, which will be, if you calculate in 3/6 feet, will be 1.52 meters, right? Okay, so when will it happen? It will happen when cosine theta minus 23.20 degrees is actually 1. Okay, so you will think about cosine, what angle will give you 1. So you should realize, okay, by the cosine curve, cosine 0 will give you 1. So theta minus 23.20 degrees will be equal to 0 degrees. So theta will be 23.20 degrees. Okay, to 1 decimal place, 23.2. Right, so what this means is that in order to get the greatest possible length for OE, right, you must arrange the table such that the angle theta is 23.2 degrees, right? Okay, so this is how you handle a question like this.